All right, so this is kind of how we want to address this first problem, what we have here. It's understood that we have two identical rectangular prisms here. Each have a height of 90 centimeters. Okay, so essentially what we're trying to accomplish here, right, as we sort of look at this one, and what's being asked of us here is we have one rectangular prism, right? It says the two identical rectangular prisms each have a height of 90 centimeters, right? And the base of each prism is a square, and the surface area of each prism is equivalent to k centimeters squared. Okay, so what that is suggesting here, in some ways, is as we sort of read this one long, right? So, and this is kind of where it's a little challenging to visualize and such, but essentially we have this prism, right? Kind of give me a little more of an angle there, but and such, and so we can kind of see that we have something that looks like this, something like this, and then like this, right? So essentially, and this is kind of where we have to tease between the words a little bit more. It says the base of each prism is square, and the surface area of each prism is k centimeters squared. Okay, so what's understood here is that the height of this one is 90, and then we have the the side and side, right? So to find the surface area of this thing, we know that the surface area is equivalent to k, right? And to find the surface area, there's two of these. So you got these bases on the end, so that's going to be s squared, and there's two of those, so that's 2s squared, right? And then you have these four rectangular faces that are all equivalent, so that means 4. And we've got to find the area of one of these faces. That's the s times the height, right? So that's 4 times s times the height, which is equivalent to k, right? So looking at this, we know the height is 90, so we can input that value. So 2s squared plus 4 times 90s equals k, or therefore we've got a total of 2s squared plus 360s equals k, right? All right, so that's the surface area of one of these rectangular prisms. And it goes on to say if the prisms are glued together along a square base. So that's talking about, if we somewhat put another one here, right, and sort of doing the same thing, right, having another one here that stacks on top of this, right, then we're coupling these together, right, and so that is suggesting that the overall area, if the area of one is k, then the surface area of both is 2k, right? And along within that is we've got 4 rectangular faces in total, but 2 of those are glued together. So that means we're subtracting 2 of those rectangular faces to get the complete surface area of those 2 rectangular prisms as they've been coupled together, right? So as a result of that, it says if the prisms are glued together along a square base, the resulting prism has a surface area of 92 over 47k. Well, we know this is equivalent to 92 over 47 k centimeters squared, right? And so that's what is going on there, right? And stuff. I think that's kind of as it reads. Surface area of 92. All right, so what we're trying to do is we're trying to find the length of each of these squared bases, or essentially s, right? So what I can then do, let me see here. We know the k's are the same unit, so we're just going to get rid of the centimeter square. So what I can then do is I can then move this over here and then move this over here to make that positive. So now that's going to read 2k minus 92 over 47k equals 2s squared, right? Okay, well, I can simplify now the left-hand side, right? I can simplify this side together. And so now as I simplify that, that's 47. Well, that's going to give me 94 over 47k minus 92 over 47k equals 2s squared. And ultimately what I want to get is I want to get 2k equals 2s squared, right? And so sorry, 2 over 47, 2 over 47k. And so now I want to isolate k, because up here I can see that this equation is equivalent to k, right? And so with that equation, I want to then isolate the k over here. So I want to multiply my reciprocal 47 over 2 here and do that over here. So that's 47 over 2. And what you'll notice is I'm going to get k equals, the 2's now eliminate, and I get 47s squared. So here k equals 47s squared, where here k equals 2s squared plus 360s. So now I can couple those together, right? I can couple the area of this, the surface area of this one, and couple to the surface area of both of them together to solve for s, right? And so now I've got 2s squared plus 360s equals 47s squared. And so what I want to do is I'm going to move both of these pieces over. I'm going to get left with 0 equals 47s squared. Well, actually, I'm subtracting 2s squared, so that's actually going to give me 45s squared. So that's going to give me 45. I think I'm wrong. 45s squared minus 360s. And I want to solve for s, so what I'm going to do, right, is I'm going to pull out 45s, so that's 0 equals 45s, which gives me s minus 8, so therefore s equals 0 or 8. And you can see that's what we have here, is that the side length of this square is, these things are both 8. And so that's how we would solve that question. So first we kind of have to understand how to use and solve for surface area. This is probably one of the most difficult problems that I have ever seen there on an SAT. One, it's a little difficult to visually sort of grasp and wrap your head around. And the phrasing, you kind of really have to tease out the words there sentence by sentence to see what you're solving for. And then you've got to understand how to maneuver through your fractions as well too on this one and stuff. So, but the answer choice on this one is B. Okay, this next one is bringing back a concept that I haven't seen from the SAT in some time. They're kind of resurrecting this one. Essentially, what they're doing is they're talking about factoring, but more importantly, grouping of factors and stuff. And so that's something that we haven't traditionally seen tested. I almost want to say since like the original SAT test that came out in 2015, and so we've never seen this. We've seen it in the practice test, but we've never seen this concept actually in a real SAT, and so it looks like with the new digital format they may be bringing this one back potentially. So what we need to do is, first off, we need to use the distributive property in this area here. Okay, so now we're going to be left with 57 x squared plus 57 bx, right, plus ax plus ab here, and all this happens to be equivalent to 0 and stuff. So what we can now do, let me see here. We can now, looking at this one, and this is kind of where we have to use the grouping, is we have to look at these terms here and then these terms here and stuff. And so what we now see from that is this one, we have an x 57 in both of these terms and an x in both of these terms. So that's going to give us 57x that we can factor out, which is going to leave us with x plus b, right? And then over here, we can factor out an a out of each one of these terms, which is factoring out that a, and that's going to give me x plus b equals 0. So this is kind of using the distributive property in the grouping. What that now suggests is we can now group these two together, right? And these can be represented by a single factor in a way. So now we can rewrite this equation as 57x plus a times x plus b equals 0 here. And so what's being said to us, it says in the given equation, a and b are positive constants. The product of the product of the solutions to the given equation are equivalent to k(a)b, where k is a constant. We want to know the value of k here. So just like we would with normal quadratic equations, in order to solve for the value of x, we have to set them equally to 0. So we would then set it up as 57x plus a equals 0 and x plus b equals 0. So this one would yield x equals negative b, and this one would then yield 57x equals negative a, and then x equals negative a over 57, right? So it's saying the product of our solutions, right? Well, these are our solutions, right? So we now know that if this is, say this is a and this is b, that we know that ab is equivalent to kab here and such. And so if we have a, which is negative a over 57, right, times negative b over, which is essentially over 1, equals kab here. And so now we multiply the two top terms. That's just going to give me a positive ab over 57, right, equals kab. So what you can see here is really this breaks down to 1 over 57 AB equals KAB. So you can see here that the K is equivalent to 1 over 57. And so then that's our answer choice A. So just to sort of recap here, this is a quadratic equation. We've got to sort of distribute our into our BX term first, right? And then out of that, we then have to sort of factor out factor from the two front pieces and then factor from the two end pieces. And then from that, we notice our patterns that we have here. And then we can use the distributive property once we notice our patterns there of having a shared term and stuff. And then from there, solve for x, find the product, set an equivalent to KAB, find the answer. Okay, the last question that we have here is referencing the quadratics again, but more specifically the vertex form. And the real hanger on this one is it's testing our understanding of a positive or negative A value. And so if we kind of briefly graph this thing out, we understand, right, that we have a vertex that's at positive 9, so we'll say this is positive 9, and then negative 14, right? So we know we have a vertex point right there, and it says it intersects. So this is the key word here on this one, is that it intersects the x-axis, right? So it's saying here, it's talking about intersecting the x-axis at 2 points here, right? Well, in order for it to intersect the x-axis at 2 points, it has to be somewhere up here, right? It has to be. So, you wouldn't, if the point's below the x-axis and it intersects it at 2 points, it wouldn't be going down. It wouldn't be doing that. That wouldn't be the case at all or anything. So that wouldn't be the premise of this and stuff. So we know as a result of this that A is greater than 0. And we've seen this concept tested in previous digital SATs and stuff. And so that's a very key reminder to understand about this one. So if we write this a form, right, we know it's y equals A, which is positive, x minus 9 squared minus 14. And we want to write it into this standard form, right? So it's understood here that if we expand this, y is going to equal A times x squared minus 18x plus 81 minus 14. And then we got to distribute the A, right? So that's going to give me ax squared minus 18a x plus 81a minus 14, right? Okay, so now at this moment we can see that the a term of this quadratic is a, and that the b term here is going to be negative 18a, right? And then the c term here is equivalent to 81 a minus 14, right? Well, as we sort of combine all these together, because it's saying a, we're trying to do a plus b plus c. If we put these in, we've got a minus 18a plus 81 a minus 14. And as we sort of then combine these like terms, we're going to end up with 61a minus 14, right? Well, it's asking, in this particular one, of the constants, which could be the following of the value of this. Well, we're trying to say, remember, a here is greater than 0, right? And so we need something here that's going to yield a positive a term here. So what we can do here is we can try using trial and error here. That's probably the best bet. So if I go and try C and see what happens, with that and solving for it in some ways, then that means 61a minus 14, that this should yield a positive a, right? So that the sum of these, because these values are the sum of all of this and stuff. If I say it's negative 14, well, if I add 14 here and add 14 here, I'm seeing I get 61a is equal to 0, so therefore a is equal to 0. Well, that can't be true, right? Because we've established that a has to be bigger than 0. So as a result of that, that is not the answer choice. And if we only get larger with our values in some ways, then we can see what's going to happen there is, it's just going to make that even further of a negative number. So if we try D in this instance, we're going to have 61a minus 14 equals 12, negative 12, right? Well, then that add 14, that's going to give me 61a equals 2, which then a equals 2 over 61, and that is now a positive term, which yields and makes this statement true and stuff. So the main thing here to keep in mind is, first we have to understand about our a term, the positive and negative. We have to understand about, vertex form and deriving that from a point. We have to then use some distributed property here to get to this piece. And then here we have to use some pattern matching to get to this piece and then go through the fact solving for the value of A, knowing that it has to be a positive term and stuff. So sort of keeping that in the back of our mind as we try to sort through this question. So I hope this was helpful. Thank you so much, and see you again.